Dear students, our new topics, next topic, power laws in an inductors. We are to discuss what will be the power laws in one complete cycles when in the circuits only a inductors. So when an inductor is connected to an AC circuits, there is some opposition of the rise and decrease of the current in the inductors. So this is our AC circuits in which an alternating current is applied to an inductor. This is our inductor. So here this is the graph of voltage. This is our voltage graph of voltage V. So it is a sinusoidal function. It's rising. It's a voltage decrease in the voltage, rising in opposite direction, decreasing in opposite direction. So this is the graph of full cycles of the voltage of an AC current. Okay. So now we also know that voltage and current are in different phases. So voltage has phase angles omega t and current has the phase angles I is equal to I naught sine omega t minus pi by 2. So the phase difference between voltage and current is 90 degree. It means that voltage is ahead of the current by an angle of pi by 2. So if I draw the graph between voltage in the y-axis, voltage and current in the y-axis, and omega t means theta in the x directions. So this is theta, omega t, actually the value of theta. Omega is equal to angular velocity is equal to theta divided by t. From here we can calculate the value of theta. Theta has the value omega into t. So this omega t would be along x directions, and the value of voltage and current in y direction, V and I. So since magnitude of voltage more than that of the current, therefore our current, this is our current value, current at different timing. Yes. So the I have drawn this our voltage ahead of this current by an angle of 90 degree. So when the voltage has the maximum value and current has a minimum value, when the current has the maximum value, voltage has the minimum value, when the current has the minimum value, voltage has the maximum value in opposite direction, and so on. So this is a graph between voltage and the current, and time or omega t or theta in the x directions. So let us start. We already know that power is equal to work done and time. Suppose in the small time interval dt, the work done is dw. Our power loss would be dw upon dt. From here to dw is equal to power into dt. So we need to calculate the average power dissipated in one complete cycle. So our average power dissipated in one cycle or revolution is total work done divided by time periods. In on one complete time taken, one complete cycles is capital T, and the total work done, if I integrate this one, if you integrate this work done, this has the value P dt. Putting the value of here, 1 upon time taken one complete cycle, integrations of P dt, P into dt. So time taken from 0 to 1 revolution time. Putting the value of P has the value here P voltage into current. So your voltage has this value V naught sin omega t, and current has the value I naught times this value sin omega t minus 90. Also we know that from the trigonometry, sin 90 minus omega t has the value cos omega t. So now if I replace this value, we have this is the value sine of omega t minus pi by 2. So we have to bring minus from inside of the sine value, minus 90 minus omega t. We also know that it comes out minus sine 90 minus omega t. So it comes out sine 90 minus omega t has the value cos omega t minus cos omega t. I have used here another formula. Sine of minus theta would be minus sine theta. So this value I have incorporated here. Sine of minus 90 minus omega t become minus sine 90 minus omega t. So this is our value of this. If I place this value in this place, so I would get minus V naught V naught I naught sine omega t into sine 90. It has the value of minus cos omega t. Minus already there, cos omega t minus cos omega t. Yes. So if I place these values here, the value comes out minus 1 upon t integration of t equal to 0 t V naught I naught sine omega t and cos omega t multiplied with cos omega t, integration with respect to timing. Now the average power becomes, if I multiply this value by 2, it would be minus 1 upon 2t, and from 0 to capital T, V naught I naught 2 times of sine omega t cos omega t. Now our value comes out from the last part of this derivation, omega t, which comes out minus 1 upon 2t 0 to time V naught I naught, and we know that 2 sine omega t cos omega t has the value of sine twice omega t dt. If I integrate these values, sine has the integrations. Since sine has the integration, sine omega t dt has the integration minus cos omega t. So now first taken V naught I naught outside, minus V naught I naught divided by 2t integrations of sine 2 omega t dt. Lower limit of the time is 0, upper limit capital T. So putting the value of integration of sine omega t dt minus cos twice omega t, it comes out minus minus already there, minus V naught I naught divided by twice t, and it has a value minus cos 2 omega t, and divided the coefficient of t, which is 2 omega, by 2 lower limit 0, upper limit capital T. there should be omega also. So now putting first upper limit then lower limit, first taken minus twice omega outside of this one, the value comes out V naught I naught divided by twice t, and here minus twice omega upper limit cos 2 omega t, lower limit 0, upper limit is time t. If I play this value, so it comes out minus minus cancel out, V naught I naught 4 omega into t, putting the value upper limit cos of twice omega t minus cos 0 minus cos 0. Cos 0 has a value of plus 1. Now we know that omega is equal to 2 pi divided by time periods, and therefore omega t is equal to 2 pi. If I replace 2 omega t by 2 pi, it comes out V naught amplitude, voltage amplitude multiply current amplitude divided by 4 omega t, and 4 omega t has a value twice pi, and also here cos 2 times or 2 pi become 4 pi, and minus cos 0 degree. Now cos 0 degree, cos 4 pi, cos 4 pi has a value plus 1, and cos 0 also plus 1. So finally I have this value 8 pi, cos 4 pi has a value plus 1, and cos 0 plus 1. So net value comes out 0. So in complete one cycle, so in a one cycle the total work done will be 0. Also the average power loss across the inductors will be 0 in one complete cycle. So the final result comes out average power is 0 in one complete cycle.